Welcome back to another video. We will be looking at rearranging fractions. When we are rearranging our fractions, we can rearrange them in ascending order or descending order. So we're going to look at the meaning of ascending order. Ascending order, we start from the smallest to the largest value. And here we have an example. List the following numbers in ascending order. We have 5, 7, 3, 2, and 0. What you're going to do, you're going to start from the smallest number and you're going to end at the largest number. So to rearrange in ascending order would have 0, 2, 3, 5, and 7. So ascending order from the smallest value to the largest value. For descending order, which is the opposite, we're starting from the largest to the smallest value. We're going to rearrange the same set of numbers. However, when we rearrange them in descending order, we're going to start at 7, 5, 3, 2, 0. So it is very important that we know the meaning of the different terms, ascending and descending. We are going to be looking on our first example, and here it is asking us to rearrange 18 over 27, 10 over 27, 7 over 27, and 21 over 27 in descending order. So for descending order, we know that we're going to rearrange using from the largest to the smallest. When we look at our fractions, we realize that they have the same denominator, right? And because they have the same denominator, what we are going to do, we are just going to look at the numerator. So for each fraction, it is being divided out of 27, which is a whole. So you have one person getting 18 pieces out of the 27, another 10 pieces out of the 27, 7 pieces out of the 27, and 21 pieces out of the 27. So what we're going to do, we're just going to rearrange using the numerator because the denominator is of the same value. So if we're going to start with the largest number, so that would be 21 over 27, and the next largest number would be 18 over 27, and the next number would be 10 over 27, and the last one is 7 over 27. That would be our answer if we are going to rearrange fraction in descending. Our next example is, we have our fractions. We have 1 over 6, 4 over 9, 5 over 12, 1 over 3. When we look at our numbers, we realize that our denominators, they are different. Because your denominators are different, what you will have to do, you will have to find the LCM of your denominators. So we're going to go ahead and find the LCM. So what I'm going to do, I'm going to write my numbers. So here I have 6, I have 9, I have 12, and I have 3. So I'm going to use the prime factorization method to get my answer. So I'm going to start dividing these numbers by my smallest prime number. So I'm going to say 2 into 6 3 times, 2 into 9 can't, so I'm going to rewrite my number 9, 2 into 12 6, 2 into 3 I can't, so I'm going to rewrite my number 3. I'm going to check to see if there's any number that is divisible by the number 2, and I have my 6. So I'm going to continue dividing by the number 2, which is our smallest prime number. So I'm going to rewrite my 3 and my 9. 2 into 6 goes 3 times, and I'm going to rewrite my number 3. The next thing I'm going to do, I'm going to move on to the next prime number in line, the smallest one, since 2 is not divisible into any of these numbers. So I'm going to use my number 3. 3 into 3, 1. 3 into 9, 3 times. 3 into 3, 1, 1. So I still have my number 3. What you can do is just go ahead and finalize. 3, you put back your 1. 3 into 3 goes 1 times. So when we look all our remainder here, everything is divisible and we get 1. So what we're going to do, we're going to just finish up. So we have 2 times 2 times 3 times 3 We can also write this in index form. And if we write this in index form, we are going to just have 2 to the second power times 3 to the second power. And when we multiply all our numbers, we are going to get 36. Same for 6, 9, 12, and 3 is 36. So what we're going to do, we're going to rewrite these fractions. So here I have 1 over 6. I'm going to write this as an equivalent fraction using 36 as the denominator. So here I have 36. So I'm going to ask myself, what did they multiply 6 by in order to get 36? So we know that 6 times 6 gives us 36. Therefore, we're going to multiply our numerator by 6 also. So 6 times 1 gives me 6. The next thing I'm going to do, I'm going to move on to my next fraction. I have 4 over 9 is equal to a number over 36. 9 into 36, that goes 4 times. 4 gives me 36, and I'm going to multiply my numerator with the same number. So 4 times 4 is equal to 16. My next fraction is 5 over 12, and it is equal to a number over 36. So I'm going to ask myself, 12 into 36 goes how many times? And I got 3. 3 times 12, 36. Multiply my numerator by the same number. 3 times 5, 15. So my next fraction, 1 over 3. So here I have 1 over 3 is equal to a number over 36. 3 into 36 goes 12 times. So what they did, they say 3 times 12, 36. I'm going to multiply my numerator by the same number. So here I have 1 times 12 is equal to 12. In order for me to rearrange my fraction in descending order, what I am going to do, I am going to go ahead and look at my equivalent fractions. So now I have 6 over 36, 16 pieces out of 36, 15 pieces out of 36, 12 pieces out of 36. Which is the largest? So when I look at it, I realize that the 16 out of the 36, that would be the largest. So what I am going to do, I'm going to write this fraction first. So I'm going to write 4 over 9. And what's my next fraction in line? So 16 over 36, then 15 over 36, which is the same as 5 over 12. So I'm going to put 5 over 12. And my next fraction would be 1 over 3. And the last one would be 1 over 6. So this is my answer. If I'm going to rearrange in descending order, I have 4 over 9, 5 over 12, 1 over 3, and 1 over 6. My second example is to rearrange in descending order 5 over 6, 7 over 10, and 11 over 20. When I look on my denominators, they are not the same. So we're going to move on to step 1, where we're going to find the LCM of our denominators. So here I have 6, I have 10, and I have 20. So I'm just going to go ahead and find the LCM. So I'm going to use a prime factorization method, and I'm going to start dividing by my smallest prime number, which is 2. 2 into 6, 3, 2 into 10, 5, and 2 into 20, 10. Is there any number here that 2 can go into without leaving a remainder? Yes. So we're going to continue using our number 2. 2 into 3 can't, so I'm going to write back my number. 2 into 5 I can't, I write back my number. 2 into 10 goes 5 times. Very good. Now we're going to move on to our next smallest prime number, which is 3. 3 into 3, 1. 3 into 5 can't, so I'm going to write back my numbers. So the next number I'm going to use, the next prime number. So we have 2, we have 3, and then we have 5. So I'm going to say 5. I'm going to put back my 1. 5 into 5, 1. 5 into 5, 1. In order to write our LCM, we're going to multiply these numbers. So here we have LCM. So we're going to multiply 2 times 2 times 3 times 5. And when you multiply those numbers, you are going to get 60. So our LCM is 60. What we're going to do, we're going to rewrite these fractions as equivalent fractions. So here I have 5 over 6 is equal to a number over 60. What did they multiply by 6 in order to get 60? That's my question. So it is 6 times 10, 60. So I'm going to multiply my numerator by the same number. 5 times 10, 50. My next fraction is 7 over 10. So what I'm going to do, what did they multiply by 10 in order to get 60? They multiply 6. 6 times 10, 60. So I'm going to multiply 7 times 6, which is equal to 42. And my last fraction is 11 over 20 is equal to a number over 60. So what did they multiply 20 by in order to get 60? 20 times 3 is equal to 60. 11 times 3 is equal to 33. Because we are writing in descending order from the largest to the smallest, what we're going to do, we're going to identify the largest fraction. So if you give me 50 items out of 60, 42 out of 60, and another 33 out of 60, this would be the highest fraction, okay? So my first fraction in order would be 5 over 6. My next fraction will be 7 over 10. And my next fraction will be 11 over 20. So this would be your answer. Very good. Remember, while you're watching this video, to like, comment if you understand what is being taught, and you can also go ahead and send us some suggestions, share with your other classmates. Now we are going to move over to looking at rearranging in ascending order. When we are rearranging in ascending order, we are moving from the smallest to the largest. So our fractions, we realize that they have the same denominator. So in this case, you don't have to find any LCM. So this is saying they are giving 9 out of 18 to one person, 5 out of 18 to another, 4 out of 18 to another, and 16 out of 18 to another. Who would be getting the smallest amount? So let us rearrange in that order. So ascending, it would be 4 out of 18, and the next person with the least, 5 out of 18, and the next 9 out of 18, and the last one 16 out of 18. So in this case, this would be our answer. Next example is to rearrange in ascending order: 7 over 10, 4 over 5, 4 over 15, and 9 over 20. We have different denominators, so we're going to go ahead and find the LCM, change them to equivalent fractions, and then we rearrange them from the smallest to the largest. So I'm going to just go ahead and write out my denominators. So I have 10, 5, 15, and 20, and I'm going to use a prime factorization method to find my LCM. I'm going to start dividing with my smallest prime number, which is 2. 2 into 10, 5. 2 can't go into 5 without leaving a remainder, so I'm going to write back my number 5. I'm going to write back 15 here. 2 into 20, 10. Can 2 go into any number here without leaving a remainder? Yes, 2 can go into 10. So I'm going to put my number 2, rewrite 5, 5, and 15, and 2 into 10 goes 5 times. My next prime number is 3. Can 3 go into any number here without leaving a remainder? Yes, it can go into 15. So I'm going to put my number 3, rewrite 5, 5, 3 into 15 goes 5 times, and I'm going to put back my number 5 there. My next prime number would be 5. So 5 into 5 goes 1 time, and this is what we have here so far. So to write our LCM, we're going to multiply 2 times 2 times 3 times 5 in order to get our LCM, which is 60. What we're going to do next, we are going to rewrite these fractions as equivalent fraction. So let me start with this. 7 over 10 is equal to a number over 60. The question is, what did they multiply by 10 in order to get 60? They multiply by 6. 6 times 10, 60. So we're going to multiply 6 times 7, and here we have 42. Our next fraction is 4 over 5. And here we have 60. What did they multiply by 5 in order to get 60? They multiply by 12. 12 times 5, 60. So we're going to multiply 12 by 4 and we're going to get 48. Our next fraction is 4 over 15. What did they multiply by 15 in order to get 60? They multiplied by 4. So we're going to multiply the denominator and the numerator. So here we have 4 times 4, which is equal to 16. And the next fraction is 9 over 20. What did they multiply by 20 in order to get 60? They multiplied by 3. 3 times 20, 60, and 3 times 9, 27. Now we are going to write our answer. We're going to look to see which is the smallest fraction. So here I have 16 over 20. This would be the smallest. Therefore, I'm going to write 4 over 16. Remember that you're not rearranging the equivalent fractions. You're rearranging these fractions: 7 over 10, 4 over 5, 4 over 15, and 9 over 20, right? So my first fraction will be from the smallest, that would be 4 over 15, and then 9 over 20. And the next one would be 7 over 10, and the next one would be 4 over 5. So that would be your answer for rearranging from the smallest to the largest. Our next question is to rearrange in ascending order, which is from the smallest to the largest: a half, 3 over 4, 7 over 8, and 5 over 12. What we're going to do, we're going to find the LCM because we have different denominators. So I have my number here: 2, 4, 8, and 12. So I'm going to use a prime factorization method, and I'm going to use my smallest prime number. 2 into 2, 1, 2 into 4, 2, 2 into 8, 4. Number 2 just the same. 2 into 2, 1, 2 into 4, 2, and 2 into 6 goes 3 times. I have another 2, so I'm going to divide by 2 again. 2 into 2 goes 1 time. And the next thing that I'm going to use the number 3. 3 into 3 goes 1 time. So here we're going to rewrite out our numbers to 2 times 2 times 2 times 3. And when we multiply, we are going to get 24. What I'm going to do, I'm now going to rewrite my fractions, and I'm going to change them to equivalent fractions using 24 as a denominator. So a number times 24 gives me, a number times 2 gives me 24. 2 times 12, so I'm going to multiply my numerator by 12. So here I have 12 over 24. My next fraction is 3/4. 4 times a number gives me 24, and here I have 4 times 6. So I'm going to say 3. So here I'm going to say 3 times 6, 18. My next fraction is 7 over 8, which is equal to a number over 24. To do, I am going to say 8 times 3 gives me 24, and 7 times 3 gives me 21. So what I'm going to do here, I'm just going to go ahead as it relates to finalizing my answer. So 5 over 12 is equal to a number over 24, and that would be 12 times 2 and 5 times 2, which is equal to 10. To get my answer, I'm just going to rearrange from the smallest to the largest. And the smallest fraction here would be 5 over 12. And the next one would be a half. And the next one would be 3/4. And the last one would be 7/8. Okay, remember that what you have to do is to practice. Remember to like, subscribe, comment, and share. And thank you for watching this video.